Okay, okay. Momentum and impulse is exactly what we are going to be talking about in today's lesson. Can you see this lot of information, honorable member? Trust me when I say we are going to go through all of it. We leave no stone unturned. The nice thing about this is that you will understand everything, honorable member, by fire, by force. I'm telling you, everything will definitely make sense. So maybe without wasting much of our precious time, just going to zoom in and we start from the beginning. Let us see. I did mention that a momentum and impulse is exactly what we are going to be looking at. So maybe let's start there and deal with this thing decisively, honorable member. You see, they are talking about that word being momentum. Okay, now the question is, what is momentum? The nice thing about physical sciences is that the definition itself, it already tells you what the formula is. So momentum is the product of the mass and velocity. That is the shortest way to remember what momentum is. The product of mass and velocity. So to speak an English that makes sense, we will therefore say it is the product of the mass of an object and its velocity. So that means the honorable member, the word product, remember it refers to multiplying things. What are we multiplying? It is the mass that we multiply together with the velocity of that mass. That's it. So with that statement alone, you can be able to derive the formula for the calculation of the momentum. Okay, what are they saying there? Momentum can be thought, a momentum can be thought of as quantifying the motion of an object. Okay, then it's fine. So the following equation is used to calculate the momentum, quantifying the motion of an object. Okay, we are trying to quantify the motion of an object. Obviously, when something is in motion, that's if it is moving. And that object will definitely have a mass. So that is why we talk of two things. That object which has a mass and its velocity. So the product of those two things, they give us the momentum. Yeah, I just thought of something. That's why in rugby, the most important thing is the momentum, honorable member. You must have a more mass and at the same time higher speed. Then you become a good player because with that mass, yeah, they won't easily take you down. And at the same time, you can still be able to run away. But imagine if you can run faster, but you are just weightless, honorable member, like a paper. They will just say, not even to say anything, they'll just blow while you are running and then you fall away. So, very much important that you've got the mass and the velocity. In that way, your momentum will be higher. Okay, otherwise, worry not about what I've just said, but let's look at the evidence presented before us, where they are saying, Evan, what is P now? Oh, P, it is them. Okay, so that means momentum is represented by letter P and not M. I think it makes sense because if we use M, we know that you are going to confuse it with the M for the mass. So that's why we now refer to it as a P. The mass, obviously, in physical sciences, mass is measured in kilograms, very much important. Velocity, you do know very well what a velocity is, and it's measured in meters per second. So that is why the unit for momentum, it will be kilograms multiplying by meters per second. So that's where that unit comes from for the calculation of the momentum. Very, very much important, honorable member. On okay, maybe let's try look at this calculation where what are they talking about? Vector nature of moment. Okay, Momentum is a vector quantity or quantity and has both magnitude and okay. So that means a momentum, it is a vector quantity which has both the magnitude and the direction. Very, very much important on that one, Honorable. It is therefore important to always include, you see in bold, to always include direction in all momentum calculations. Why? Because it is a vector. So you can't just say it is 40 kilograms meters per second and you leave it there. Especially that in the statement, they might mention to say in this direction, up or down, left or right. So you should maintain that direction. Okay, so let's look at that example where they are talking about a golf ball of mass 0.05 kg. Okay, very, very much important, honorable member. The mass may be given to you in grams, so you need to convert it to kilograms. For example, if they say it is 500 grams, you will therefore have to divide it by kilo means 1,000, so by 1,000, so that you get an answer which is in kilograms. Be very, very careful of that, honorable member. So, okay, 0.05 kilograms leave a golf club at a velocity of 90 meters per second. Yes, the unit must be in meters per second. If it is given in kilometers per hour, you need to convert it to meters per second in an easterly direction. Very, very much important, honorable member, on that one. So it is not just moving, but in an easterly direction. Whether you say easterly or easterly, it doesn't matter that much. On whether you were wearing a pullover or a blazer when you were going to school, on at the end of the day, it is it in an easterly or easterly direction. Okay, calculate the momentum of the golf ball. That is the momentum is the P, which is equals to the mass that is multiplying its velocity. So you can see there, we need to make a decision to say we choose east as positive. So remember, a compass is like this. You have north, you have east, you have south, and you have west. So better take east as positive because on a Cartesian plane, on the right hand side of the origin is positive, and then on the left hand side is negative. Up, obviously, positive, and then down, negative. So what is it that we are going to make it positive between M and V? It is the V. Why V? Because V, it is a vector quantity. So that is why it makes it automatically the P to be a vector quantity. The mass is a scalar quantity. It does not have the direction. So that means this thing is 0.05 for the mass and positive 90 meters per second. Very, very much important on that one, honorable member. Multiply the two and then you get that. Most importantly, the unit and again the direction, because you just calculated a vector quantity. It is as easy as that, honorable. You see this topic, it's where you need to score some serious some serious marks, because this is one of the easiest topics. Yes, it may be tricky and all of that, but you will realize that it may be tricky, but not that much complicated. Okay, then it's fine. So now let's see, change in momentum. So when a net force acts on an object, now we are talking about the forces. Okay, when a net force acts on an object, it results in change in velocity for the object and therefore a change in momentum for the object. So the change in momentum can be calculated using this formula. Okay, so let's actually revisit this statement. They are talking about a net force, which is acting on an object. So this net force, it will result in a change in velocity for the object and therefore a change in, okay, no, I think it makes sense. So in other words, they are simply saying that if there's a net force acting on an object, obviously it will influence its velocity. So the velocity may either increase or decrease. So that increase or decrease will definitely have an impact on or change on the momentum. So if there is such a change, therefore there is a formula that can be used to calculate that change, where we look at the initial momentum and the final momentum. So that is why the formula looks like that. This thing, it's a Greek symbol which refers to delta. Delta means change. So how you can think of change, think of it as final minus initial, like the final situation minus the initial situation. So here, again, that means when you see this, always refer to this as change in P, because there is that delta and there is P for momentum. So that's why we say change in momentum. Nay, still measured in that because it is a momentum. So now they say change in momentum. What I know is that change means final minus initial. So it is forced to be P final minusing P initial. Why? Because we are talking about change in momentum. Again, momentum final will still be measured in the same unit as the initial momentum. Maybe when we do some calculations, that's when it will make sense in terms of what goes to final, what goes to initial. Okay, due to the vector nature of momentum, it is very much important to choose a positive direction. Okay, we will see that as we continue. So let's see. What are they saying there? They are talking about a 1,000 kilogram car initially moving at a constant velocity of 16 meters per second in an easterly direction. Approaches a stop street, starts braking, and comes to a complete standstill. Okay, now it makes sense, honorable member. They want you to now calculate the change in momentum of that car. So it's like we're talking about a car which has a mass of 1,000 kg. So that car, initially, it was moving at a constant velocity of 16 meters per second in an easterly direction. Then it approaches a stop street, and then the driver starts applying the brakes, and then it comes to a stop or stand still, which means they apply the brakes and they stop because maybe it's a street where there's a stop sign. So now they want you to calculate the change in the car's momentum. Of course, it changes because it was moving at 16 meters per second, and then they apply the brake, it gradually decreased until it come to a stop. So obviously, we do know what the formula is. Momentum final minus momentum initial. It should be easy in this way because let's see. We will therefore say east, we take it to be positive. Okay, so now let's see. We are definitely going to say 1,000 because that is the mass of the final situation where it has stopped. So be careful of this, honorable member. The formula says momentum final minus momentum initial. And the momentum final, it refers to the end situation. What happens in the end? It comes to a stop. That's why the zero goes there. And then we minus it by the initial situation. Initially, that same object of mass 1,000 kg, it was traveling at 16 meters per second. So that's why the 16 goes there. Nay. Then now you move that on your calculator, you got your answer to be negative 16,000. Nay. And then you say, therefore, the final answer, it becomes, you no longer write it as a negative 16,000 because in physical sciences, the sign always tells you the direction. Not to say it is a smaller value, because negative is smaller than, for example, positive 16,000. It doesn't tell us about that being a smaller value, but it tells us about the direction. It's like if someone claps you with a 50 Newton and another one claps you with negative 50 Newton. It's not like this clap is painful than that one. No, it could be that this was a positive clap on the right side of my face. And then this one, it was on the left side of my face. But the pain, it is still the same as 50 Newton. I hope you get it now. So now, as what is it? Someone who does physics, is it a physician, not physician, but physics no, something. Okay, you get it. If you don't get it, forget about it. Okay, then it's fine. We are now going to write it as a positive 16,000 kilometers, not kilometers. What am I smoking now? 16,000 kilograms meters per second. Yes. Now, in terms of the sign, you are going to say west. Why west? Because the answer that you got, it was negative, whereby you assumed your east to be positive. So if you got a positive final answer, you were going to say east. But because you get an answer in the different sign, then it is the opposite of east, which is west. So if it was north or up, then you would therefore substitute accordingly, assuming up to be positive. Then if you get a final answer being negative, you would therefore say down. Yes, something of that nature, honorable member. Maybe let's look at this example and see what's happening there. So here's an example where they talk about a cricket ball with a mass of let's see, a cricket ball with a mass of 0.2 kilogram approaches a cricket bat at a velocity of 40 meters per second east. Very, very much important. Okay, east, and leaves the cricket bat at a velocity of 50 meters per second west. I hope you have a better understanding of what's happening there, Andre. You know cricket most. There is this one who is going to throw this thing, throw it to that one where this one has got that bat thing, and then they are going to moor it with a bat. So this tennis ball, as it is going there towards that, is traveling at 40 meters per second, meaning initially it is having that speed. It is the same object having the same mass, and then east positive, but now after it gets moved, it is now moving in the west direction where it was coming from. So that means it's going to be negative 50 meters per second. It is still that object of 0.2 kilograms. Very much important on that one, honorable member. So now we need to calculate the change in momentum or the change in the ball's momentum during its contact with the cricket bat. So that is why, honorable member, because the question said the change in momentum, we will pull out this formula for the delta, where we say equals a momentum final minus momentum initial. As we expand that formula, we know it's mv final minus mv initial. Very, very much important. Be very careful here. It is that same mass, but the final situation is that it leaves the bat at 50 meters per second. But which direction? West. So that means you have your east as positive, and then the opposite of east is going to be negative. Can you see? That is why it is substituted as negative there. And then the minus is for the formula, the mass still the same. This one is substituted as positive 40. Why? Because we assumed east to be positive. Very, very much important, honorable member. And then now you put it on your calculator, you get your answer as negative 18. So that negative, we know negative means west. So that is why we will conclude to say, therefore, the change in momentum equals 18 kilograms meters per second west. So that's how you get full marks after writing the magnitude and the direction. Very, very much important on that one. A honorable member or the member who is honorable. Okay, it's fine, it's fine, it's fine, it's fine. Let's see. I think on the next lesson, I would like to just actually take you through Newton's second law of motion, where we are going to expand on this formula that you are seeing there, and also get to the impulse. And then from there, I think we will be ready to do some more with regards to the momentum and the impulse. But otherwise, it's fine. I'll leave it here for now and say until we meet again. Until